Okay guys, so now we're going to start getting into talking about refraction, okay, a concept that actually plays a massive part in your specification. So we're going to take, like we did with our experiment within class, a glass block. Okay, now the first line we need to talk about, just as a little bit of recap, is this imaginary line called the normal line. Now in the normal line, we know that when we consider waves as being wave fronts, and there is a little bit of a discussion to be had here about whether we should consider it as a wave, we should consider it as a particle, and we discussed this idea that Higgins' principle states that each wave front is a source of particles that each emit sources of oscillation. Now you can take it at this point that constructive interference occurring, because the waves are essentially in phase, they're going to cause the wave fronts to all create this line here. So we'll take that just for now. All right, now what you have between this point here, we call this point B, and this material A, you've got a difference of density here. Because all the waves enter the block at the same time, what you get is all of the waves slowing down. They all slow down at the same time, therefore they all travel through at the same time, and they end up leaving at the same time as well. So what you get is no bending of light, although the line isn't perfectly straight the way I've drawn it. All right. The next thing we'll be looking at is how to consider the angles when they come in various points, and how to start making some calculations.